Hi everyone, welcome to Wisdom Academy YouTube channel. This is Satish. Today we are going to teach about CBSE first chapter, real numbers. Okay. What is number? The basic origin of maths is counting. After people started counting, they believed that number starts from 1. Then people found there are negative numbers. Before finding 0, people found the negative numbers which is found by Chinese. Then later in India, Brahmagupta found 0. And he also found the operations of negative numbers. So, think, if I ask what is number to some 5th standard or 4th standard guy, he may say numbers is counting just, and he knows only about natural number. That is, number starts with 1, and if I ask any people, as not a maths teacher, if I ask anything, they will say that number starts with 1. But number starts with 0, they found in the later part. Okay, so lowest number, so see naturally in LKG, UKG or first standard, the first grade student, they say that 1 is the least number that we found. After that in 2nd standard or 3rd standard, people came to know about 0 and they told that 0 is the least number. And once in 3rd or 4th, up to 5th, people started teaching about integers which has negative number. Then we generally believed that there is no any other number between 1 and 2. If I ask how many numbers are there in between 1 and 2, a common people may say there is no number. But there are infinite numbers, that numbers are known as rational numbers. Okay, then there are numbers which cannot be expressed in the form of P by Q. Generally, the numbers which can be expressed in the form of P by Q is known as rational number, where Q should be not equal to 0. And you know that why it should be not equal to 0, because if it is equal to 0, then it will be undefined. It has no value. So then another thing is irrational number, which cannot be expressed in the form of P by Q. That is, after a decimal point, without recurring, numbers will be keep on coming. Example is pi. Pi as not finishing, it is a golden ratio, it will never finish. All these number systems together we known as real numbers. Okay. In this video, we are going to see about why this number system is named as real numbers. Why not something else? See, whole number means they thought after this there is no any other number. That's why they told whole number. After finding integers, negative numbers, they find that this is the whole number, nothing else, no other numbers are there. Integers indirectly means whole only, everything. So, everything. Then they started this. Rational number, it's named because of the ratio. Since numerator and denominator has some ratio, it is named as rational number. Since opposite of rational number is named as irrational number, everything else is named as real number. Okay. If there is a real number, something else opposite, imaginary, it should be there, right? Yeah, there is a number called imaginary number that you will be studying in class 11th. Now we are going to see about Euclid division lemma. First of all, who is Euclid? Euclid is a 3rd century mathematician who gave a book called Element. From that book, we have several proofs and laws in the mathematics. Okay. Then what is lemma? Lemma means which is unnoticed. Something in the mathematics which is unnoticed, we will call it as lemma. We know about theorem, right? Similarly, it is lemma. Okay. So what Euclid division lemma states, that is, a given positive integer a and b, there exists a unique integer q and r which satisfy a is equal to bq plus r. What it means? If I am dividing a number 31 divided by 3, how it will be? 31, 3, 10s are, my remainder is 1. And if I am dividing a 32 by 3, then my remainder will be 2. If I am dividing a 30 by 3, then my remainder will be 0. In this, what Euclid observed is 0, 1 and 2, this remainders. That's what he is saying is, my remainder, when I am dividing, it will be greater than or equal to 0, but definitely it will be less than my divisor. If I increase the number by 1, now it will be 33 by 3. Now my quotient will increase, but my remainder once again will go to 0. If I further increase one number, I will increase the remainder by 1. By this way, all the numbers can be expressed in the form of a is equal to bq plus r, where my a and b are unique integers. We are speaking about only positive integers. Here we are not speaking about negative integers. That you have to note, very important thing. Okay. Now, using this Euclid division lemma, what are the applications are there? One of the most important application of Euclid division lemma is Euclid division algorithm. Using Euclid division algorithm, we can able to find HCF of two numbers. We already know how to find the HCF of two numbers, right? We have already having a prime factorization. That method, using prime factorization, we will find the HCF. Before going to that, what is HCF? If I throw this question to a third or fourth, fifth guys, they will say HCF means highest common factor. But people doesn't know what is inside it. First, what is factor? Factor means the number which divides the other number completely. Whatever number which divides the other number completely is known as factor. Then if you take 30, 10 is the complete factor, 5 is the factor, 3 is the factor, right? So now common factor means if two numbers having common factor. For example, let's take 24 and 32. Now what are all the factors of 24? Definitely 1 is the factor, 1 will be the factor for all the numbers, you know, right? Now 2, since it is an even number, it will be divided by 2. Then 3, addition of this number is 2 plus 4 is 6. So definitely it will be divided by 3. And the other factor is 4. And another factor is 6. Then other factor is 12. Then 24 itself. Okay. One more factor we missed, which is 8. Right? In 8 tables, so 8 3s are 24. Now for 32. Once again it will be divided by 2. 1. Then 2. Not definitely by 3, then it will be 4, then 8, then 32. Right? Now, if you compare these numbers, one more we missed, 16. We compare these numbers, these are the factors of 24, these are the factors of 32. Now, the greatest number which can divide the given numbers is known as HCF, right? In this, 1, 2, 3, 4, 6, 8, 12, 24 are the factors of 24, and 32, 16, 8, 4, 2, 1 is the factors of 32. In this, which is the greatest number? See, which has common. So in this, which are the common first? 0, 1, 2, 4, 8, and 16. Okay, now this 1, 2, 4, 8 is known as common factors. So common factors for 24 and 32 are 1, 2, 4, 8. Okay, and highest common factor is in this 1, 2, 4, 8, which is the highest? 8. So 8 is highest common factors for these two numbers. Okay, now since it is a small number, I can able to find in this method. Let us think the number like 12,576 and 4052. How to find HCF of these two numbers in easy way? Definitely this method can be done, but it will take some time. To reduce the time, Euclid division lemma gives some algorithm. Euclid division algorithm consists of 3 steps. The first step is apply Euclid division lemma to A and B. A and B must be a positive integer, and it should be a whole number, right? So, and we will get a whole number called Q and R in such a way A is equal to BQ plus R. That's what Euclid division lemma says. And my R will be greater than or equal to 0 but less than B. Okay. The step 2 is, after finishing this, we want to check whether my remainder is 0. That is, if R is equal to 0, then I can decide my B is my HCF. If it is not, then we have to apply my Euclid division lemma to my B and R. That is, after applying, there will be B and R, right? If it is R is equal to not 0, then I want to select my B and R and I want to continuously apply my Euclid division lemma. That's my third step. Continue the procedure until the remainder becomes 0. So that's what I done for 12,576 to 4,052. So if I use the prime factorization method or other method, it may take much of time. Now, the 12,576 can be expressed as 4,052 into 3 plus 420. Now I will check my remainder. My remainder is not 0. So I am going to go for the step 2, that is, I am going to take my divisor and remainder. I am going to once again apply my Euclid division lemma. So I will check 4052, 420, which is greatest number. So 4052 will be my A and 420 will be my B. and 420 into 9 plus 272. That way we can express my 4052. Now once again I will check my remainder. My remainder is not 0. So once again I am going for it. So 420. For 420 and 272, I will apply like this. 420 is equal to 272 into 1 plus 148. If I divide this, I will get the remainder as 148. Once again my remainder is not 0. So I am going to continue for 272 and 148. 272 can be written as 148 into 1 plus 124. Now once again my remainder is not 0. So I am going to continue this procedure until my remainder is going to be 0. Now what number I have to take? 252 and 148. So I will take that number 148 and 124. So 124 into 1 plus 24. So once again here my remainder is not 0, it is 24. So I am going to continue my equal division lemma for 124 and 24. 124 is equal to 24 into 5 plus 4. Now my remainder is not 0 once again. I am going to select my 24 and 4 and I am going to do once again equal division lemma. Here I got my remainder 0. What it means? For 12,576 and 4,052, the highest common factor is 4. What are the other numbers that may be the factor? 1, 2. After 1 and 2, 4 is there. After that, so after 4, any greater number than 4 which will not divide 1,256 and 4,052. So this is what equal division lemma says. So equal division lemma in other places also we can use like this general purpose. In this purpose, the question is show that any positive odd integer is of the form 4q plus 1, 4q plus 3 where q is some integer. What it means? Generally any number can be expressed in the form of this thing, right? So I will write a is equal to bq plus r. By comparing this statement, I can say 4 is my b, right? So I can write a is equal to 4q plus r. Now since my divisor is 4, my condition for equal division lemma is 0 greater than or equal to and less than my 4, right? In this case, what are all the numbers are there? 1, 0, 1, 2 and 3. So this is the number set for this, right? Okay. Now what they are saying? Show that any positive odd integer. So odd integers. So all the positive odd integers will be in the form of either 4q plus 1 or 4q plus 3. Now we can take the case. Case 1. I will take r is equal to 0. If I take r is equal to 0, then if I substitute r is equal to 0, then what I will get? A is equal to 4q plus 0, which is equal to 4q, right? And 4q can be expressed as 2 into 2q, right? And I am taking, let 2q be my m. So I will have 2m. So any number format, 2m will be known as even number, right? Any number which is multiplied by 2, whatever number, let it be 3 or 5 or 7, odd number or even number, whatever, if it is multiplied by 2, then that number will be resulting in even number. So it is even. So what is the number format here? A is equal to 4q plus 0. Now I am going for case 2. Case 2, I will take remainder as 1. Now my format will be A is equal to 4q plus 1. Now I can take A is equal to 2 into 2q plus 1, right? Let my m will be here 2q. So 2 into m plus 1. In any number format, the number 1 greater than multiplied by 2 will be odd number. For example, if I take m as 2 here, 2 into 2, 4, 4 plus 1, 5. If I take m as 6 here, 2, 6 are 12, 12 plus 1, 13. So whatever I do, this number will end up in odd number. So I will say this number is odd. And I am going to my case 3, where my remainder will be 2. So A is equal to 4q plus 2. I will take 2 as common outside. So what will be remaining inside? 2q plus 1. I will take m is equal to 2q plus 1. So it will be end up in 2m. Once again, it's a multiple of 2. So it will be a even number. So even. So now I am taking the case 4, where r is equal to 3. So A is equal to 4q plus 3. Here, this 3 can be written as 4q plus 2 plus 1. Did you agree? That is 3 can be written as 2 plus 1. So now I am taking 2 as common outside. So it will be 2q plus 1 plus 1. So let m is equal to 2q plus 1. So 2 into m plus 1. Once again, this will be a odd number. So according to our statement, show that any positive odd integer is in the form of 4q plus 1 or 4q plus 3. Now these are the two odd cases, right? These are the two odd cases. In this odd cases, what is the format? 4q plus 1. In this odd case, what is the format? 4q plus 3. Hence proved. So this kind of sums also we can do. That is, generally we can take one module or any number, and generally we can prove that whether what type of number we are going to be resultant. So this is one of the application of Euclid division lemma. Okay. So this is one of the important sum in the 10th book. So what it says is an army contingent of 616 members is to march behind the army band of 32. So what is the case? 616 members are there of army parade. So they are going to parade. In that 32 members are there in the military band. That is the people who will go for music. So the two groups are to march in the same number of columns. They have to form the same number of columns. Have you seen that march, right? It will be of perfect squares, a perfect rectangle. They will march very linearly. So this is what is the maximum number of column in which they can march? So here the two numbers is, one is 32, another one is 616. So 32 members has to go front and 616 members has to behind, they has to follow them, and maximum columns we has to form. The first condition is there should be not any reminders. That is, in a row, if there isn't 3, there should be completely 3 members has to be formed. The easiest way of forming this is, we can make, so this is 32 number of music band and 116 members of military guys. 616, sorry. So this 32 and 616, we can just form one column. There will be no remainder, right? If I do it with 1, there will be no remainder because there is no chance of remainder. One is going to stand behind one another. So there will be no remainder. But here, note the word maximum number of columns we need. So, yeah, we can go for 2. If I make it 2, see, check 16 rows, this will be filled. And here 308, 308. This will be filled, right? So 308 people will be standing like this. So this will be filled. So 616 people will be filled. Yeah. So now also no remainder. But 2 is the maximum. We can't able to say. Then we can go for 3. If I go for 3, I will face a problem. Like 32 is the number which will be not divided by 3, right? So in 10th row, I will face a problem with, in 11th row, I will have only 2 people and 1 place will be remaining, which is not allowed in this sum. So I can't able to use 3 columns. So I will go for 4. If I go for 4, what will happen? So I will have a military parade of 8 rows and 616 also I can able to make. So 4 columns. From this what we conclude is 1, 2, 4, these are the common factors of 32 and 616. That's why there is no remainder. So 32 and 616 we are finding the common factor, and here we need the maximum number of rows. So what is the least idea we can go for? We want to find HCF of these two numbers. To find the HCF to these two numbers, we can go for Euclid division lemma. Once again, I will explain this. See, in a military parade, 32 members has to go in front, that's a music band, and 616 members has to follow. And we want to form the perfect numbers, that is, there should be no remainder. So we cannot form a row with the 2 members and 1 remaining or 2 remaining. That kind we should not form. So the obvious thing is we want to form the numbers in the common factors. If I take 1, there will be no remainder. If I take 2, there will be no remainder. The size will be reduced. Number of columns will be 2, so number of rows will be reduced. So like that I can do, but 3 cannot be done because 3 is not the common factor of these two. If it is asking the 3 is having the common factor, then that will also satisfy. 4 is the common factor of 32 and 616, so that will also satisfy. So in this way, since 4 is also doing, we can conclude 4 is the maximum column that we can build. So that we are going to find HCF of these two numbers using equal division lemma. So to find the equal division lemma, we want to do the steps. Hope you remember that. Step 1 is, we want to choose which is the greatest number of 2. That one we have to take it as A. So A will be here 616 and B will be here 32. So I can express as A is equal to BQ plus R. So 616 can be written as 32 into what number plus what is the remainder. So for that I have to divide 616 32. So if I divide 616 by 32, so it will my quotient will be 19, my remainder will be 8. So I can express as 32 into 19 plus 8. So what is the second step? I have to check my remainder. Whether remainder is 0? No. If my remainder is not 0, I will select my B and R. Once again continue my equal division lemma. So here 32 is equal to, we can write 8 into 8 into 4 plus 0. Now I have the remainder 0. So I can say 8 is my HCF of, so HCF of 616 and 32 will be 8. So 8 is the maximum column which can able to form. Other than 8, no, if I form, it will be not forming. That is, if I form 8, my military band will be of 4 columns. And my 616 members will be divided by 8 into 19 columns. So there will be a 19 rows for 616 and there will be a 4 rows for military band. So they will follow this. So this is the maximum number of columns. In this way also we can use equal division lemma. Okay guys, soon we will add some more extra sums in the description. You please solve it, and if any doubts, please don't hesitate to ask in comment, we will do it. Then next video we are going to do it on fundamental theorem of arithmetic. And in the starting of the video I told why the real number is called as real number, because that the number we are using in the real world. So there are, I already told about the imaginary number that you are going to study in the 11th, that will be in the imaginary world. That number we doesn't know how it is going to be. Okay, thank you.